Okay, in this video, I'm going to take you through a few questions in preparation for the January exam. A few questions on probability and discrete random variables. So the first question on prediction is as below. The Venn diagram shows the events A, B, and C and the associated probability, where P and Q are probabilities. So we have the Venn diagram here with the set A, probability for event A, and the probability for event B, the intersection of A and B, and the probability of an event occurring outside A and B. So the first question we have, when the probability for B occurring. So we come to the working for the part of the probability for B. Since we know that the total probability is equals to 1, we need to add all the probabilities in the Venn diagram and they should add up to 1. What does that mean? So we have 0.04, 0.06, P, EU 0.3, 0.4, which is equals to 1. And we add the 0.04, 0.06, and 0. We're going to work now is this given range number of times, each time starting with the bar containing balls as described above. When the variable x represents the number of yellow balls represented in a single bar, we to find the probability distribution of x and find the expectation of x. So let's start 0.3, 0.4, we get 0.8, which means that p plus q is equals to 1 minus 0.8, and therefore p plus q is equal to 0.2. And because in the Venn diagram, the event B, as shown here, is P, Q, and 0.3. Those are the only probabilities inside B. So we're going to have P plus Q plus 0.3 to be equals to the probability for B, which eventually gives us 0.5. And that's done. So we go to the next question. Determine whether or not event A and B are independent. To find whether two events are independent, we are supposed to find the probability of an event occurring A and the probability of event B. We multiply the probabilities, then we find the probability of the intersection of the two events. And if the two probabilities are equal, then the events are independent. So the probability for A is 0.04, 0.06 plus P plus Q, which is equals to 0.3. We have probability for B, which is 0.5. The intersection of these two probabilities from the Venn diagram, we can see it is P and Q. And we already know that P and Q gives us what? 0.2, shown here. So if we multiply the probability for A and the probability for B, which is 0.5 times 0.3, gets 0.15. 0.15 is not equals to 0.2, and therefore the events A and B are not independent. And that is it. So we move to another question. We are given that the probability of C given B is equal to the probability of C. Then you're going to find the value of P and the value of P of Q. So what do we do? The probability, this is conditional probability, the probability of an event C occurring given that B has occurred, which we use the probability formula. The probability of C given that B occurs is the probability of C intersection B defined by the probability of B. We already found the probability for B, which was 0.5. Don't know the probability of C intersection B, which is supposed to be equals to what? Which is supposed to be equals to P. So the probability of C given B has been certain to be equals to probability of P of C. probability of C from the Venn diagram, probability of C from the Venn diagram here is supposed to be 0.06 plus P. So it is 0.06 plus P. We are going to equate 0.06 plus B equals to P over 0.5, where P over 0.5 is from the probability formula that the probability of C intersection B defined by the probability of B, which is P over 0.5. So if we put that and make P the subject of the formula, we're going to have 2P equals to 0.06 plus P, which is going to give us P equals to 0.06. We already have the value of P. We want to get P and Q. So since we already know that P plus Q is equals to 0.2, we can get the value of Q, which is 0.14. And that is done. Then we move to question part C. Part D. The event D is such that A and D are usually exclusive. So if the probability of B intersection D is greater than 0, we are supposed to, on the Venn diagram, show a possible position for event D, knowing that it is mutually exclusive with A. So B being mutually exclusive with A means that B cannot be inside set A. It can only be outside. They don't have anything in common. So we can only have B inside B or overlapping with B. It's overlapping. So we're going to have B here. That can be D, or we can also have D inside B. Either of these is going to make the event D because it's mutually exclusive with A, and there is an intersection between D and B. So, as we have said, it shouldn't be outside A because the probability of B intersection D is greater than 0. And the whole of question 1 is done. Move to question 2, which is testing us another question on probability with the tree diagram. We are on the 3 bags A, B, and C, each contain colored balls. Bag A contains 4 red balls and 2 yellow balls only. Bag B contains 4 red balls and 1 yellow ball only. Bag C contains 6 red balls only. In a game, Mike takes a ball at random from bag A, reference the color, and place it in bag C. He then takes a ball at random from bag B, reference the color, and place it in bag C. Finally, Mike takes a ball at random from bag C and reference the color. Your turn to complete the tree diagram. Opposite to illustrate the game by adding the remaining grudges and all probabilities. Then we need to show the property that Mike returns available exactly twice is 1 over 10, showing that. Then given that Mike returns exactly 2 yellow balls, we need to find the probability that the ball thrown from bag 8 is red. This is proportional probability. Where we reckon our event of Mike throwing ball that is thrown from bag 8 is A, and exactly 2 yellow balls is event B. In the tree diagram, so that we can know the probabilities that we will be using. So the tree diagram is down here. We have probability of picking a red ball from bag A, which is 2 over 3. So we can get the probability of getting a yellow ball A, which is 3. Then we have the probability of getting a yellow ball from bag B, which is going to be 1 over 5. This might be as yellow balls. Then we are going to have the probability of getting a red ball from birds being 1 because the birds in C were all rent and we have added 2 more rents. This is supposed to be like 8 out of 8, which is just simple 1. And getting a rent after placing a red and a yellow, the total becomes 8. Initially, the total was 6. So the total becomes 8. Sorry for this. Just put the limit. So the probability getting a red C after placing a rent and a yellow is going to be 7 out of 8. This is because initially we had 6 red balls in but C and we added 1 more. Then let's move to getting a yellow from the bag C. We never end a yellow, but you put 1 yellow inside bag C. So now we have the probability of 1 over 8. We come to picking a red after picking a yellow in bag A and picking a red in bag B. So the total becomes 8 and the probability of getting a red now becomes 7. 8 instead of 6 because of 1 addition of the red 1. And last trip we're going to have we have got a yellow ball from bag A and a yellow one from bag B, and eventually we are going to have a probability of 6 over 8 of getting a red ball from bag C and a probability of 2 over 8 of getting a yellow ball from bag C. So that is it for the tree diagram. After the tree diagram, we have question B. What is question B asking? Show the probability that Mike reckons a yellow ball show the probability that Mike reckons a yellow ball exactly is 10. You want to know that that's probability is 1 over 10. So if that probability is 1 over 10, so question B is over here. It's exactly yellow balls. It can either be the first picking was a red ball followed by a yellow and another yellow, or the first one is a yellow followed by a red, then the next one is a yellow, or the first one is a yellow, the next one is a yellow, and the last one is a red. That is yellow exactly twice. So the probability of picking red and yellow is going to be 1 over 2 over 3 times 1 over 5 times 1 over 5, which is going to be 1 over 20, 2 over 20. Then the probability of picking a yellow, red, and yellow is going to be 1 over 3, 1 over 4, is 1 over 8, which is going to be equals to 4 over 120. Then the probability of picking a yellow and a red is 1 over 4 times 1 over 5 times 1 over 8, which is going to be 6 over 120. So this is going to give us a total probability of 2 over 120 plus 4 over 120 plus 6 over 120, which is 2 over 120. Simply simplifying to 1 over 10. And question B is well done. We move to question C. What are we told in question C? We are told that given that now brings the quotational probability. So given that Mike performs exactly 2 yellow balls, this is just the probability that we just found in question B. Find the probability that the ball drawn from bag A is red. So let's try to change this question to rewrite this question in a different way, but meaning the same meaning. When the probability that the ball drawn from bag is red, given that Mike performs exactly 2 yellow balls. So find the probability of A given that B occurs. So let's go ahead and do question C. Okay? So the probability of A given that B occurs is going to be given by the probability of A intersection B defined by the probability of B, which is intersection B. Intersection B. The first ball picked from A is red, and exactly two yellow balls are picked. That is RYY. And then the probability of having exactly two yellow balls is going to be Y and Y, Y, R, and R, Y. So, okay, so we're going to have 2 over 3 times 1 over 4 times 1 over 8 for R by Y, that is red, followed by a yellow and another yellow, which is going to give us 2 over 120. And then the probability for B we already calculated in question B, which is 1 over 10. And when we divide that, the mathematics we get 1 over 6. That is the conditional probability. So we've been able to answer question C. Let's move to part D. Before we answer part D, find the probability distribution of F. We need to understand the statement here. Might plays this game like number of times, each time starting with the containing balls as described above. The random variable x represents the number of yellow balls recorded in a single game. Alright, we need to make a probability distribution for x. When we know that x actually is the number of yellow balls recorded in a single game. Right. Let's see. X will take 0 yellow. That is when all recording is for red. And take 1 yellow and the red, yellow or red, and the yellow, red, the yellow, and the red, it again, red, red, and the yellow. Then yellows. Plus 2 yellows. Yellow, yellow, red, red, yellow, yellow, red, yellow. The last one is when all are yellow. So we have the probabilities from our tree diagram. So from the tree diagram, we know when we can get the yellow, which we can confirm the probabilities in the tree diagram here. Red, 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 and red, yellow, and red. That is one yellow. Red, yellow, yellow. That gives us two yellows. Another two yellows would be yellow, red, yellow. That's another two yellows. So when we multiply 1 over 3 times 4 over 5 times 1 over 8, and we add 2 over 3 times 4, 1 over 5 times 1 over 8, we're able to get the probability for getting two yellows. We also need to add 1 over 3 times 1 over 4 times 1 over 6 over 8. That gives us 2 yellows and 1 red. 12 out of 120. Then we get yellow, yellow, yellow. All recorded are yellows. That is 3. So 2 out of 120. Where do we get that from? Yellow, yellow, yellow. 1 over 3 times 1 over 5 times 2 out of 8. And that is how we get it. So we distribute the probabilities on a probability distribution table, and we will be able to find the expectation of x. That is the mean of x given by the formula summation of xp. Every x value times the probability. Every x value times the probability. 2 times 0 over 120, 42 over 120, 0, 3 times 2 over 120, which gives us 3, 6 over 120. Eventually, this gives us 0.6. Done. That is done for question 2. And this is kind of a question that really doesn't meet in it. So we move to question 3. This brings the idea of now discrete random variables. So what does the question require us to do? The discrete random variable y has the following probability distribution Y values are -9, -5, and 0, 5, and 9. The probability that the discrete random value of y takes the values y, we have q, r, u, r, and q. Alright. Where q, r, u are probabilities, we want to write down the value of the expectation of y. What do we do? Let's look at the distribution. We have a symmetry. 5, -5. 9, -9. So at the center, this brings an idea of a normal curve. That is why our expectation automatically is going to be 0. Move to B. Show that the value of U is 4 out of 15. So let's see how we show that. So we know that f of 0 is 19 over 30 given. The cumulative distribution of y is f of y. We have that. Given that f of 0 is 19 out of 30, that's why we're getting that. So f of 0 is 19 out of 30. And that means that when we add q plus r plus u, we should get 19 out of 30. And when we add all these probabilities here, look, beyond all these probabilities, q, r, u, r, p, we shouldn't be able to get 1. So when we add twice of q plus r plus u is supposed to get 1. What does that mean? So q plus r is 19 over 30 minus u. So we move u to this other side. So minus u on both sides of the equation. This means we can substitute q plus r in the second equation. So we are going to have 2 m to 19 out of 30 minus u, then plus this the u in the equation, we get 1. And from there, we are able to make u the subject of the formula. 19 over 15 minus u, which is going to be equals to 1. If we minus 1 on both sides of the equation and we add u on both sides of the equation, u becomes 4 out of 15. So let's move to C. What are we given for C? Given also for the variance of y is 37, find the value of q and the value of r. Let's see. Value of q and the value of r. The variance is already given, and we know the formula for variance is supposed to be equals to what? Expectation of y squared minus the expectation of y all that squared. But expectation of y is 0. Wonderful. So we now need to get the expectation of y squared, which is supposed to be summation of y squared p. Every y value times the p value. Every y value times the p value, and this is supposed to be equals to 37. There is one good thing we know, that q plus r is equals to what? 11 out of 30. We have a simultaneous equation. And we can make r the subject, which is going to be equals to 11 minus q. Let's substitute this value of r where r is. So this is going to become 50 into 11 over 30 minus q. Now, let's make q the subject of the formula. So if we make q the subject of the formula, 160q, 162q minus 50q equals to 37 minus 55 over 3. Then we are able to get q equals to 1 over 6. Getting q equals to 1 over 6, we have q plus r equals to 11. We already had that. We can make r the subject of the formula. 11 out of that, you minus what? 1 over 6. That is the q value. What do we get? 1 over 5. R obtained. We have r, we have q. We already had q. Done. We move to question D. The coordinates of a point P are 12, y. So the x value is 12, the y value is y. The random variable D represents the length OP of OP. Find the probability distribution of D, which is representing what? The length of OP from the origin O to the point, to the coordinate, or to the point P. Alright, so let's see how we should be able to go about D. You know, D is representing the length. So for the length to be 0, for the length, sorry, so y is equals to 0 is our first value of y. So when we know y is 0, what will OP be? Is going to be the square root. This is the modulus. OP is going to be the square root of 12 squared plus 0, which is 12. What about y is plus minus 5? What will be the distance? When I do 5 squared is 25 and negative 5 squared is still 25. So this is just going to be the square root of 12 squared plus 25, which is going to give us the square root of 169, which is 13. Let's get the other distance. What about when y is plus or minus 9? Y is plus or minus 9, we're going to get b being equals to the square root of 44 plus 81, which is going to be the Alright, so we move on this other part of getting the distribution of OP or the distribution of D, which was supposed to be obtaining the distances for the various values of y. When y is 0, our distance is going to be 12, because we're going to use the modulus formula, which is 12 squared plus 0. The square root of that gives us a 12. And then the other one is supposed to be when y is plus or minus 5, which is going to give us the square root of 12 squared plus 25, which is equals to 13. And then the last one, which is supposed to be plus or minus 9 for the value of y, and that gives us the modulus, the square root of 81 plus 144, which gives us the square root of 225, which is going to be equals to 15. Therefore, probability for y equals to 0, we already had it, which was 4 over 15. Probability for y being plus or minus 5, which is 1 over 5 plus 1 over 5 gives us 2 over 5, and that gives us the probability for D being equals to 13. The 4 over 15 gives us the probability for D being equals to 12, and the probability for Y being equals to plus or minus 9, which is 1 over 16 plus 1 over 16 gives us 2 over 6, which gives us the probability for D equals to 15, and therefore the probability distribution of D becomes the values that D was taking is 12, a distance of 12 that we got, a distance of 13, and a distance of 15 gives us a probability of for 12 we have 4, out of 15, for 13 we have 2 out of 5, and for 15 we have 2 out of 6, and to confirm that your probabilities are correct, make sure that you add all the probabilities and they should give you the value of 1. Nice. And that's how it is supposed to be. Sorry about that. Thank you so much for watching.